So, slides please. Yeah, so today I'm gonna give you a lightning talk on deep funding, which I think is one of the most exciting mechanism experimentation that's currently happening in our Ethereum ecosystem. So, quickly, let's talk about open source and open source dependencies because we all rely on that. Very famous graph. We built these large modern digital infrastructure projects, and there's this guy, this random person from Nebraska that has been thanklessly maintaining this crucial piece on the open source dependency stack, right? And why is that important? Because your bags of money, when it comes to Ethereum dependency, depend on this random guy from Nebraska doing his job really, really well. You can look that this is, for example, on the top, these are all the liquidity exchanges built on top of the DeFi apps, and that is built on top of digital infrastructure like Geth, MetaMask, Parity, the Ethereum 1 blockchain, and all of this tech we need, and is a public good actually, to create our ecosystem, to keep it performant, keep it secure, right? So that our bags of money don't collapse. But if you look at how this random guy from Nebraska is right now raising money, he doesn't have a lot of time to develop, he doesn't have a lot of time to maintain, he needs some kind of, because it's open source, some kind of funding, which is either a side hustle, which his dependency probably is, or he needs to apply for grant applications. That is not a way for a sustainable and healthy ecosystem that is the Ethereum ecosystem. And so Vitalik, he came up with like this really simple and fancy idea, which I think is actually a paradigm shift in our community, because we talk a lot about blockchain and AI, but this might be one of the first use cases where we believe it's actually very scalable and useful. So he talks about deep funding, and that's something I want to introduce you to today. So deep funding is a coalition of several partners in the ecosystem, VoiceStack, Gitcoin, Allo Protocol, Open Source Observer, Drips, Pairwise, Evil Science, which I represent, and Vitalik himself, that has been proposing a new idea to fund these critical dependencies. And how it works is basically we trickle down funding from the seed graphs nodes into its dependencies. And then this random guy from Nebraska, once more, is maintaining this since 2003, but making a ton of money. And that's the hope. So how does it work? Well, it requires two components. It requires a deep dependency graph, and it requires deep learning. That's why it's called deep funding. So let's go step by step. So deep dependency graph. We basically propose to map Ethereum's ecosystem through dependencies, starting with Ethereum itself in its core protocols and repositories, 34 seed nodes. And then from that, we analyze all its dependencies through software dependency analysis and derive more than 4,000 child nodes on the first layer. And that initially can go deeper and deeper and deeper. But let's start with this layer first for visualization. Then next, this is how it would look like after we mapped it out. These are the 34 seed nodes in red, and the rest blue parts are the 4,000 child nodes. That data set is already publicly available in our GitHub repository. We're gonna label that data set now, and how we label it is we ask Ethereum's core maintainers and some of the most important people in our ecosystem. So how it works is Vitalik proposes 2 judges, these judges proposes 2 more judges, these judges proposes 2 more judges. So we have an exclusive list of judges that all they do for the next couple days is to label thousands of these dependencies in a pairwise comparison, saying, okay, given node A, node B, which one would you give more money in, right? And so we collect all these weights. We create a machine learning training data set with pairwise comparisons where the weight is the probability of you getting funding from that judge. And then we perform deep learning, trying to see if we can train a machine learning model that can distill human judgment and scale it to the whole dependency graph. And how we do this is, of course, we give you that training data set, and we expect you to bring your own data. LLMs, GitHub APIs, scores, reviews, whatsoever what you need. We run then this model into the whole rest of the dependency graph. We keep a certain kind of test data secret from the judges to evaluate how well your models align with the secretly labeled data set. And that should run hopefully according to millions of comparisons. And that is the competition. So the jury has this secret test data set, and in the end, we're gonna be like, okay, AI model number 3 is pretty well aligned to whatever the Ethereum community, the judges themselves, think that is a really cool and distillable judgment. But we envision that future actually to be more interesting than you think. So as we are scaling this competition of multiple machine learning models, trying to predict the weights of which dependency should be funded or not, you can imagine a future where you as a funder have a certain kind of preference that you would like to fund, for example, code quality that is really high, or someone who wants to fund code that is produced from certain kind of developer groups that are marginalized. And you can start labeling your own small test data set and see which of the models that have been submitted aligns the most to your funding judgment. And so we think that deep funding is a really interesting approach that's right now happening, and open source is just the start, because dependency graphs exist all over our community. It exists in retro public goods funding, it exists in our science and research through citation graphs. So to cite Kevin, that is open source is just the start. We believe that deep funding could be, as an algorithm, scaled to many more public goods mechanisms than just software and maintaining our dependency stack. So the competition started a couple weeks ago actually, and V has pledged 250K, 170K to be dispersed by these winning AI algorithms, 40K for the best model, and 40K a special prize for really interesting solutions and ideas. And this is the platform where we are submitting right now. It's pond.xyz, where you can submit your model. We measure the prediction error depending on mean squared error. And you can see that currently, this is a snapshot from just today, how we have more than 5,000 submissions, and several of the members are already striking a really, really nice error margin here. Yeah, if you want to learn more, visit deepfunding.org, and I'm here for questions.
David, thank you very much. Yeah, I'll just pass the mic.
Thanks for the talk, really, really good. I'm curious to see if it makes sense when you evaluate projects and you sort of have this pairwise testing. Am I right to assume that this requires those people to have a lot of knowledge? And then the other question would be, are there maybe instances of dependencies that are so niche and so rarely known that they would be neglected in pairwise comparisons just because maybe just one or two people really know of them or are aware of them?
Very good question. So it definitely requires expert knowledge, but we believe that the jury design, how we are right now doing it, is pretty flexible. So we actually don't disallow the jury members themselves to use AI models to distill information and help them support. The pairwise labeling module that we implemented also drags some GitHub API scores and metrics for you to compare directly one-on-one. So you're not starting from scratch. You're starting already with an interface that provides you minimal information. I agree with the thing that potentially niche dependencies are undervalued, but we hope that everywhere a little bit of signal comes to the niche dependency when we do it at scale, such that the distribution is still reflected in a fair manner.
After the initial testing phase, where do you see the funding actually coming from in the long term?
So we believe that deep funding itself is certainly like some kind of a pledge. Protocol Guild could propose some parts of the money to deep funding to fund the rest of the dependencies. And we believe in the future, in the long term, 1% of all the deep funding money itself should go to deep funding itself, because the measurement and the improvement of the algorithms should, of course, also be funded.
What are other use cases that you are excited about beyond open source software?
As a recovering academic and scientist, I think this is one of the most powerful ways to fund independent scientists. So imagine right now the citation graph itself. Right now, when you're working in science and you're not part of an institution, you're maybe part of Ethereum research or your own small nonprofit lab, it's really difficult for you to apply for Swiss national funding and other resources because you're lacking that institution reputation. But deep funding on the citation graph can provide finances depending on how well you're cited, how important you are in the graph. So I think that is a really interesting area that if these algorithms work really well in open source software, this could be the next step we're looking into. Yeah, please.
So suppose there, in the dependency graph, there are some projects that have already received like millions of dollars through RetroPGF from Optimism, but now in the pairwise comparison, they are still like valued because they are super impactful.
Yeah.
Is there some kind of a proposed mechanism to take into account how much funding they have already received, or is that part of the judgment in the pairwise comparison? How are like the judges supposed to know, or is there some kind of thinking around that, or is that kind of a later problem if this really works?
We do right now analysis on the human judgment that we have received so far from the judges and past funding and see how much that is correlated. It does have a correlation coefficient, but it's not very strong as we expected. So, but definitely there is a correlation. One of the things we can imagine this to happen is in the deep funding round that is personalized, you can yourself account for this. Because imagine you're MetaMask and you want to donate some of the money back into your dependencies. And then you know that certain kind of dependencies have received a lot of money, and you can instinctively, through the labeling of your initial private test data, could assign this consideration implicitly. And then the algorithm itself could distribute it out. There are also ways where we are working right now with agent allocation, so large language models that can get a prompt and allocate. So some of our users have actually submitted large language models. And in these large language models, you can even put it potentially as a prompt, as a value that, hey, I would like to use you, model number 321, but like with this specific prompt of not using too much funding.
Thank you very much. Thank you, David, for all the great insights. I think any startup needs funding, so this is a great initiative. And it's been amazing to have you here. Our next session is starting in 4 minutes. And those, big applause.